Hey everyone. Cool. Thank you guys for having me. Thank you WorkOS for hosting this. Yeah, let's kick this off. So I'm Mohammed. I'm a developer relations engineer at Daytona. At Daytona, we build infrastructure for running your agents and their workloads on our cloud. We call these computers or composable computers for agents because you or your agents can configure them for any given task, like CPU, RAM, disk. You can add GPUs, and we expose this through a very easy-to-use API. And to clarify ahead of time, we aren't a wrapper around the cloud provider. We are a cloud provider. We have our own bare metal servers, and we build and manage the full stack, and that's a big reason why we can achieve the latency and the concurrency that we do. That being said, you can also self-host this on your own compute. And so, like, why is it that you might be wondering, like, okay, why, what's the difference between this and like EC2 or something? There's kind of this, so recently, well, not super recently, but like when you use AI agents, like they're generating code way faster and a lot more than humans. That's arbitrary code that, like, at this point people are reading less and less of. And so you kind of, if you want to execute those on traditional VMs or traditional infrastructure, because the shape of it is a lot different from like human code, the isolation, the speed, and the persistence starts mattering a lot more. And this is kind of like the fourth point is why you might have been seeing like a lot more sandbox providers pop up, and why even the hyperscalers themselves are kind of releasing their own sandbox for agents product. Is this fourth point, like the isolation, the speed, and the persistence, kind of different ways of achieving that, and with different trade-offs. And so this is kind of how, this is sort of what we are. I'm going to zoom in a little bit if you guys can see that. But yeah, we have an API for you to spin up VMs and choose the exact image, the resources for any given task. You can make it it could last however long you want, or it could be ephemeral and delete itself after it's done with whatever work it's doing. And I'll go into some of the use cases now. I think this is how we're currently being used right now, and maybe this will be some inspiration for your guys' projects. So I guess the most obvious one is like running coding agents on the cloud, right? So agents generating code might not be, you might not want that to run on your own infrastructure, especially if you're a company that provides cloud agents to users, because you can imagine, like, if you're letting that code run on your own infrastructure, you're gonna have to like manually, if you don't want to be like hacked or whatever, you're gonna have to manually check that code, or you could make it so it's isolated. And then also we have computer use. So yeah, computer use agents, you can give them a desktop. You can, we have Linux and just released Windows as well. So any GUI task, or if you're training computer use agents, that's what we're used for right now. And speaking of training, for reinforcement learning, so a lot of these really big training jobs require a lot of sandboxes running at once, and they require those sandboxes to be spun up and down really, really fast, because you can imagine if your GPUs are idling on waiting for like code to be executed or anything of that sort, then that's a lot of time you'd be wasting on idle compute. And then also, like, so CI runners, going back to like how agents are generating a lot more code, there's a lot more PRs being created. And so like these things that were kind of built assuming the speed of humans start to kind of fall apart when trying to keep up with the speed of agents. And so that's another way that people use us. And then for your own, if you're an enterprise and you don't want any like data, or you want to kind of own your data, you want to make sure you can see everything that comes in and out of those sandboxes, and you're maybe building your own agents. That's another way that people use us. And then, like, for example, AI scientists or AI like research agents, and yeah, we recently got GPUs, so that's another way you can use us. Some other features, so yeah, less than 90 milliseconds to spin up a sandbox and execute code, your build per second. And we have SDKs in the most popular languages. And then, as I showed earlier, we have an API and a CLI. Some other features. So we have container sandboxes. We have VM runners as well, Windows. You can attach GPUs to them, snapshot a running sandbox, fork it, and make it so, yeah, spinning up as many sandboxes as you want as fast as possible. And then a lot of our features, we keep in mind like how agents work and sort of build that into our product, but we also have like naturally kind of things that humans would still care about. So yeah. And you can, if you want to self-host it on your own compute, you can do that. We have a secrets manager, so you can see, you can kind of make sure everything is isolated. You can block certain websites or IPs and make sure, yeah, we make it very easy to kind of configure these sandboxes to be as restrictive or as free as you would like, depending on your, whatever you want to use it for, and as observable as possible. So yeah, you can get started for free. Obviously, hackathon participants get free credits for today's hackathon, but we also have a startup program. So if you're a startup or a lab or a small team, whatever the case may be, we offer up to 50K in credits and compute credits for your startup. You also get added to our Slack and get personal help from engineering, quota increases, early access to features, all that. So yeah, highly recommend scanning this QR code and signing up. And yeah, anyone has any questions or kind of feedback on project ideas, you can come up to me or anyone on my team, and we can help you out. But yeah, thank you all for listening, and good luck.